Okay, now, ordinarily, I would not write out the rules for you. But this being your first time, just want to make sure that you've got the rules in front of you, you know what to do. In preparing for a test or an exam, especially in the pre-calculus class, you're gonna have to know the rules. Okay? And, but almost everybody, on almost every problem, applied the rules correctly. Okay, so this one, we apply the first rule. Log of a product is the sum of the logs. So the log base 5 of 2x is log base 5 of 2 plus log base 5 of x. They're straightforward, one-step application of the first rule. And the second is one-step application of the second rule. So this would be simply 2 log base 5 of x. Because the log of a to the b is b times log of a. The exponent comes out in front. Okay? For this one, do this in a couple of steps. We could first say, well, I'm going to write it out with a's and b's. Okay? This is log base a of x to the b plus log base a of y and the backward apostrophe c thing, whatever your numbers are for a, b, and c, fill those in and you got the result. Okay, but there's another step, of course. And one thing I saw and frequently see is sometimes people put this b outside of the parentheses, but it doesn't go there. Okay, because the x to the b is all inside these parentheses. The x to the b has to be all inside of these parentheses. It's x to the b and y to the c that we take the logs off. We don't do the log of x and raise it to the b prime. Okay. And you want to write that out carefully. Just pay careful attention to notation. Well, then log base a of x to the b by the second rule is b log base a of x. And log of y to the c is 3 times the log of y, the log's base a. Okay? So whatever your a, b, and c, and about half the class got everything completely right on this. Other half is doing good stuff and got a lot of it right. Okay? Or most of it. So I think you're in pretty good shape there. Now, we had a question about one of the homework problems. It was okay, let's write it down. Okay, now we got a slightly more complicated expression here. Somebody had a question on this. So it's a good example. Well, come on, we'll do a little bit. Let me come here. Okay, that's what it is. And it's now here, but it looks like this. Okay. Yes, we have reference to these rules. Yeah. Yes, we have reference to these rules. Do this. Okay, so 3 log to the base 4 of 2x plus 1 and 2 log base 4 of 2x minus 1. So we can apply the second rule in each of these. We've got a number out in front of the log. We can write that as log of whatever's inside raised to that power, right? So just going backwards in the order that we saw here, this has got to be then log base 4 of 2x plus 1 raised to the third power. And then this is minus log base 4 of 2x minus 1 raised to the second power, and then plus 2. Okay? Well, they're throwing a little bit of a curveball at you here, but you have to understand your intermediate algebra. How is 2 related to 4? 2 is the square root of 4, right? Okay. So 2 is a power of 4. It's 4 to the 1/2 power. Okay. So we can combine these two. How do we express this as a base 4 log? Okay. Well, four to the 1/2 equals log base 4 of what? Okay. Now, we can play around. Log base 4 of 4 raised to the 4th power. Which is just 4 log base 4 of 4, which is 4. 4. 4 times 1. 4. Okay, well, that's how we get 4. So log base 4 of what power of 4? Could equal 2. Got a number here. I wrote that as 4 to the 1/2. And 4 to the 1/2 is 2, of course, and there are ways to get around that, but I guess you just want to see this simple connection, right? So 2 is log of base 4 split. Again, we could express generally log of the base 4 of 4 to the n equals n log base 4 of 4 equals n times 1, which is n. Okay. If we want to get a number here, we just do the log of whatever base of the base to the n. It'll work every time. Okay, so anyhow, we can combine these. I'll combine them 2 at a time, although we could do all 3 at once. Okay, I'm going to say that applying the rule, of course, we have the rule for subtraction. If it's log A minus log B, it's log A over B. Okay. I didn't write that rule down because it's really a subset of this rule, or it's a combination of these two. Anyhow. Right. Like so. Okay. And then it's plus log base 4 of 4 squared. And that equals log base 4 of 2x plus 1, 2 over 2x minus 1 squared times 4 squared. Okay. And that equals log base 4 of 16. That's 2x plus 1, 2, 2x minus 1. Okay. Now we could have written all this at once. First of all, we could have written 4 squared is 16 anytime we wanted to. But just seeing this, we see that it's going to be the log of this divided by this, multiplied by this. Just using the rules. Okay. In other words, we did them 2 at a time, so we applied the rules exactly as they're written. So having done these 2 to get this, we applied the rule to this sum. But if you've got a big sum and difference, you can just do them all at once. Okay, and it works out. Okay, so I think we're in pretty good shape on this. Okay, everybody seems to have done well on the quiz. And all the stuff that I wrote over here on the right comes out. But it came down to this log of the base 4, 4 to the n is n log base 4 of 4. And that's n times 1, because log base 4 is 1. That's okay. And I played around with a couple of examples of how we do this. You know, how you can kind of, if you're not sure what to do, how to get 2 as a log, you start writing down some base 4 logs, log base 4 or 4 to some time. Okay. And then you pretty well say, oh yeah, well that's what happened. And then I kind of summarized it here. So the idea there is, if you're not sure what to do, go scratch a bunch of stuff down that makes some kind of sense, it seems to be related, and hope you stumble on the right thing. Okay. And once you stumble on it, then you know what to do when you see constant. Okay. And we'll go. Okay. Going to pose a problem here. Okay, we're talking about compound interest and the way that works. About 10% is easy. 10% annual interest. You do the arithmetic for a couple of steps without much use of calculator. Okay. Although if you got a calculator, by all means use it for the second step. If you invest $1,000 at 10% annual interest, how about it annually. How much do you have after 1 year? See if you can answer that question for me. If $1,000, well, so we want to make sure we understand the terminology, but okay, well, clearly. $10% of $1,000 is 0.10, so 0.10 times $1,000, which equals 100. Now, one thing, if you use the percent button on your calculator, put shoe goo over the thing or something so you can't use it anymore. Don't use the percent button. Percent button is a shortcut and it doesn't have any real meaning as far as what a percent means. Just something you punch to get a percent. A percent is 10% means 10 per 100, right? 10 per 100 means 10 over 100, which is 0.10. Okay. And the rule is, of course, you can just move the decimal 2 points to the left because you're dividing by 100. So you have to understand this. And having a percent button handy in your calculator is no way to understand this. Okay. So again, there's a misuse of the calculator if you've been allowed to use the percent button extensively and not write out the steps in the meaning of it. Okay. It's okay to use the percent button to do this, but if you don't write it out this way first, you're not talking about what a percent means. Okay. It's important to understand what the percent means. So I want to emphasize that. It's real important, real fundamental to what we're about to do. Okay. So you have $1,000 plus $100, right? This is your interest. You have your original principal plus your interest. Which is $1,100. Okay. Now, how much after the second year? Okay. 10% is easy. After the third, you're not going to write out all the words. You should understand all the words, and you should be writing out all the words until you're sure you understand it. But we're going to write out all the calculations. After the third year, well, the 10% of $1,210 is $121. Everybody can do that. No problem. Then you take the 1210 and add your 121, you get $1,331. Then we'll do one more here. So that's $133.1. And of course, since we usually do things in dollars and cents, take that $133.10. It's not necessary to do that. That's 12 times 131. Number 1464. Okay. Now you see, every year you're earning more, right? First year you earn $100. Second year you earn 110. Then you jump up to 121. Then jump up to 133.10. So your amount is increasing faster and faster. As a matter of fact, your amount is increasing exponentially. I'm just going to mention this. Your function turns out to follow an exponential first. Okay, now you're in the early part of the exponential here. But if you keep your money in there long enough, it's going to go up very rapidly. Okay. So I'm going to summarize all this on a table. So we start have $1,000. Okay, here are the calculations for the first year. And here's what the calculations mean. Which year is it? Well, I say start. But instead of start, I'm going to call this year 0. And after year 0, well, at the end of a year, in your first year, you're now at year 1. And your amount is 1,100. And the amount at the end of the year is top 21. Yeah. Okay. So that in year 2, 3, 4, well, now see this number at the end of the year is the number you have at the beginning of the year. And then And it's not 1221, it's 1210. Yeah, you keep going. There's your scheme. Now, a more efficient way to calculate it. Go back to year 0. Have $1,000. We multiply I'm skipping this thing where I calculate the interest. So what I'm doing is I'm multiplying 1,000 times 1 plus 0.10. Gives me the same result, doesn't it? Okay. Why is that? It's because 1,000 times 1 is 1,000, right? And 1,000 times 0.10 is the interest that we make, right? So multiplying by 1 plus 0.10 gives us our amount, gives us the money we have, plus the interest. Okay, so after year 1, we have our 1,100. Except I'm going to write it as 1,100. I'm going to write it as 1.10 times 1,000. Of course, 1 plus 0.10 is 1.10. So it's this, but 1 plus 0.10 is 1.10. We remember that this means we multiply whatever we have by 1, so we still have it, but we add whatever we get for the interest, okay? So we can write this as 1.10 times $1,000. Okay. I need to space my row with that additional line. So at year 1, we have this. So what do we have at year 2? Well, at year 1, we had 1,000 times 1.10, which was our 1,100. And we multiply that by 1.10. Now you might wonder why we do that. Well, okay. Thinking binomial expansion, confuse myself. One step ahead. And I'll keep this a little more compact. Actually, I want to write out some of those. What have I done? I multiplied 1,000 times 1.10 by 1.10, which gives me 1,000 times 1.10 squared. Because 1.10 times 1.10 is 1.10 squared. There's going to be a pattern that emerges very quickly. So after 2 years, at the beginning, of the year, we have $1,000 times 1.10 squared. I need to write that lower. Okay, so what do we end up with at the end of the year? Should have drawn these lines originally, but we have 1,000 times 1.10 squared times 1.10 is that 1331. Of course, that's the same as $1,000 times 1.102. So at the beginning of year 3, we have this, and we can continue the process. Okay. So this tells us that after 1 year, we have 1,000 times 1.10. And we could write that as 1.10 to the first power. So after 1 year, we have this. After 2 years, we have this. After 3 years, we have this. That makes sense? Every year we multiply by 1.10. So after 3 years, we will have multiplied by 1.10 3 times, which is equivalent to multiplying by 1.102. So can you give me the expression for how much we would have after 10 years? Without calculating the years in between. What, 10 years, how much is that? You don't actually have to calculate it, but write out the expression for it. In other words, what would go in this first column next to 10th year? Didn't record that, so I'm going to say it again. Well, okay, I wrote this down. I forgot to record. After 10 years, well, if you just think of extending this table, when you get to the 10th year, you're still going to have the same pattern. After 10 years, you're going to have this. Well, if the pattern continues, that's what you're going to have. But why does the pattern continue? Because every year you're multiplying by 1.10, which is equivalent to adding 10%. So after 2 years, what's the expression about it? Okay. Okay. So again, we see that after 2 years, we've multiplied by 1.10 2 times. So here's our amount. Now, if f of t stands for our amount after 2 years, Well, here's our amount after 2 years. So F of T must equal this, right? Otherwise, F of T wouldn't be the amount after 2 years. So F of T is $1,000. That's 1.10 to the T. Now, what kind of a function is this? Okay. A lot of you have it, not everybody does. It's, okay, F of T is an exponential function. Okay, is an exponential function. Is in the form A times B raised to the T power. So I'm saying that F of T is A raised to the B power. What's A and what's B? Okay. Well, F of T is this. In the form of F of T is A B to the T. And we identify A and B. Well, here it is and here it is. What's B? B is the thing that's raised to the T power. What's raised to the T power? 1.10. So B of T is 1.10. And A is the thing that's multiplied by B of T, which is $1,000. And I kind of use colors to emphasize that. B is raised to the T power. 1.10 is raised to the T power. A is the thing that's multiplied by that, which is your $1,000. Okay. Now that relates back to the graphs that you looked at in the previous section. If we were to graph this, the graph would look just like the graph of any other exponential function. That's a graph of your basic exponential function. We can label the axes. Like here's T, and here's F. Now my question is, what are the coordinates of this point? Okay, so the question is, what coordinates of this point? Well, first of all, this point would be zero, F of 0. What's F of 0? Well, you plug in 0 for T. 1.10 to the 0 is what? 1. So you multiply 1 by 1,000. It's 1,000. Okay. Now I don't know if you calculated the 10th year amount. So if you do, I'm thinking you end up with something close to 2,600. Okay. So after 10 years, F of 10 is about $2,600. Where's 2,600? Well, if 1,000 is here, 2,000 would be here, 3,000 would be about here, and 2,600 would be about here. So this is 10. This is y equals 2,600. Here's our point 10. 2,600 dollars. Okay. Now we have a scale for that graph. Well, if you look at that graph, how much you think you have after 5 years? Write down the number you think you'd have after 5 years. So I've seen estimates from 1,500 to 1,700. Okay. And all those are reasonable. I mean, looking at a graph up there and graph that I drew, not going to be all that accurate. If you sketch the graph carefully, it's reasonable if this is about halfway between 1,000 and 2,000, isn't it? 1,500. Now, if you locate this point just a little bit to the right, you can get 1,700, right? Okay. Then you kind of test that against reality. You got 1,000 here and you got 2,600 here. Halfway between 1,000 and 2,600 would be a number that lies along this line, right? That's a line with a slope of 1,600 over 10 or $160 per year. Kind of your average interest over the first 10 years. It's worth thinking about that statement, but don't worry about it right now. The point though is that on this line, you would be halfway between 1,000 and 2,600, which would be at 1,800. So you know that this line goes above the graph because the exponential function is constantly rise. So you know it's going to be less than 1,800. The only question is how much less. If you kind of use that, you can make a better estimate and understand what the graph is telling you even better. Okay. I think I'm going to just walk over to that. So you don't compromise your identity. Okay. You gotta be careful about that. Actually, we do. So probably not in this situation. Don't worry, there's nothing back there you can break. Actually, if you look hard enough, you'll probably find something. Don't worry about it. Okay. Now, so anyhow, we see this, right? And of course, if we continue our table, our table went up to the 4th year. Okay, and we had like $1,460. Okay. If you add 10% of that, you get a little over $140. It's usually something pretty close to $1,500. Okay. So you kind of get an estimate here that you can check by the numbers and check out and make sure you really understand. Now that's the way compound interest works and why you get an exponential function. You get an exponential function because your interest is 10%. You multiply by 1.10 for every one of the t years, starting with your initial amount. It's an exponential function, a b to the t, with a equal to $1,000 and your base equal to 1.10. If we wanted to find when that doubles, we could solve the equation. We looked at that last time, so I'll just mention this as a closing comment. We solved the equation. Thousand times 1.10 t, which equals 2,000. We divide both sides by 1,000, we get 1.10 to the t equals 2. Now we use the logarithm. We did that last time. Okay. And we find that t is about 7 years. It's about 7 years for the money to double at 10% interest.